Welcome to Dave Matson. So today we're going to continue on linear programming, but on this topic, exclusivity. So if you haven't liked and subscribed, ensure you do so and turn on the notification bell to get notified whenever I drop more videos like this. That being said, let's get into the activity of today. Now, in solving a problem concerning exclusivity, let's see a question. It says a specialist toy manufacturer produces two versions of a particular toy. The deluxe model uses 5 units of material, 3 hours of machine time, and 2 hours of unskilled labor time. The standard model uses 4 units of materials, 2 hours of machine time, and 3 hours of unskilled labor time. Now, in an attempt to keep the deluxe version more exclusive, the manufacturer has decided to produce not more than 50 of these in a week. Each week is able to allocate 400 units of materials, 200 hours of machine time, and 250 hours of unskilled labor time to production of the two versions of toy. Every unit of the deluxe model produces a profit of 12 naira, and every unit of the standard model produces a profit of 14 naira. Formulate a linear programming program to maximize profits without satisfying all the constraints. So this looks very long because of the requirements. So let's shorten them out. So you can say example. We have two versions of toy. All right. So the first one is deluxe. So let the deluxe version be represented as X. And the second one it says is standard model. Let the standard model be represented as Y. All right. So now it says the deluxe model uses 5 units of material. So we can say profit. Let's keep it for now. Subject to 5 units of material, which is for deluxe 5x. All right. 2 hours of unskilled labor time, 2x, and okay, let's see, 5 units of material, 3 hours of machine time. So let's say 3 hours of machine time and 2 hours of unskilled labor time. Then the standard uses 4 units of material, 4y, 2 hours of machine time, 2y, and 3 hours of unskilled labor time, 3y. So this is a maximization problem, less than or equal to. Now, in an attempt to keep the deluxe version more exclusive, the manufacturer has decided to produce not more than 50 of these. So we have a constraint, not more than 50 in a week. So each week is able to allocate 400 units of material. So this is for materials. For the first one, 400, second one, 200, and for the third one, it says 250 of unskilled labor time, and is not to go beyond the boundary of producing 50 in a week. So every unit of the deluxe model uses a profit of 12 naira, and deluxe is represented as X, so we say 12x plus, and every unit of the standard uses a profit of 14 naira. We have 14y. So remember, our non-negativity is where x is greater than or equals to 0, y is greater than or equals to 0. So this is for material, machine time, and what's the last one? Labor time. So as usual, we'll pick the first one. From material being 5x plus 4y equals to 400. When x is equals to 0, y is equals to question mark. So 5 open bracket 0 plus 4y equals to 400. 5 times 0 is 0 plus 4 y equals to 400. 4y equals to 400 divided by 4 divided by 4, y is equals to 100. Then do the same thing. When y equals to 0, x is equals to question mark. So that is 5x plus 4 open bracket 0 equals to 400. 5x plus 4 times 0, 0 equals to 400. 5x equals to 400 divided by 5 divided by 5. X equals to 80. So, next one. From machine time, whereby we are giving 3x plus 2y equals to 200. When x is equals to 0, y is equals to question mark. So this is 3 open bracket 0 plus 2y equals to 200. 3 times 0 is 0 plus 2y equals to 200. 2y is equals to 200 divided both sides by 2. 2y equals to 100. Alright? Now, when y equals to 0, x equals to question mark 3x plus 2 open bracket 0 equals to 200. 3x plus 0 equals to 200. 3x plus 0 is 3x equals to 200 divided both sides by 3 over 3. 3 cancels 3. X is equals to 200 divided by 3, giving us 66.6666, but we can call it 66.67. Alright, and from the last constraint, from labor time, which we have 2x plus 3y equals 250. Alright, when x equals to 0, y is equals to question mark. So this is 2 open bracket 0 plus 3y equals to 250. 2 times 0 is 0 plus 3y equals to 250. 3y equals to 250 divided by 3 divided by 3. Y is equals to 250 divided by 3, giving us 83.333. So you can say 83.33. Then when y equals to 0, x is equals to question mark. So this is 2x plus 3 open bracket 0 equals to 250. 2x plus 0 equals to 250. 2x equals to 250 divided by 2 divided by 2. X is equals to 125. So now we've known this. So we can write our coordinates being for the first one, which is material x, or since it's y that is starting, y is equals to 100, x is equals to what? 80. For machine, y is equals to what? 100, x is equals to 66.67. And for labor, y is equals to 83.33, x is equals to 125. So through this, you can put this in a diagram, and this is what it will look like. This is y-axis. The highest for y here is 100. So we can say this is 110, 100, 90, 80, 70, 60, 50, 40, 30, 20, 10, and 0. The highest for y is 125, almost 130. So, for x. So this will be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, and 130. x as is. So for the first one, when y is 100 at this point, x is 80 at this point. So they will come to each other. All right. Next one, when y is also 100, x now is 66.67. Now, this is 66.67. Almost is greater than 66.5, which is half between 60 and between 66 and 67. So should be a little bit here. So connect this to meet it at this place. The next one is when y is 83, just a little bit above 80.33, x is 125 in between 120 and 130. So this one come this way. Exactly. Now, remember something from the question. It said, in an attempt to keep the deluxe version more exclusive, the manufacturer has decided to produce not more than 50 of this in a week, which I wrote earlier on. So there's a constraint of not going beyond point 50. So this will look like this. This is a boundary on its own, differentiating this from every other one we've treated on linear programming. So as usual, since this is a maximization because we're to get a profit, we're dealing with the innermost. Here becomes our A, here becomes our B, this point becomes our C, following this line, here becomes our D, still on the innermost, not here, and here becomes our E. So these are the innermost constraint. Because of this 50, we're not to go beyond this 50, unless we would have just followed the line to this inner one. But since here is a constraint, here becomes our 50. So through this now, we can get our corner points. Corner points will look like this. We have our elements of variables, and call it x, y, and profits. So we have elements A, B, C, D, and E. 5 elements. So we have A, we have B, we have C, we have D, and we have E. For A is at 0.0 for Y and 0.0 for X. For B is at 83.3, remember, for Y, and coming down to 0 for X. For C is neither touching any of them. So draw a dotted line to 20, 75. For D now is at 0.50, which stretches down for X, and at 20 for Y. E at 0.50, then 0. So remember, the profit which was given, they said it's 12x plus 14y. So this will become 12 open bracket 0 plus 14 open bracket 0. This is 0 plus 0 equals 0 for A. 12x plus 14y equals to 12 open bracket 0 plus 14, 83.33. So this is 0 plus 14 times 83.33 gives us 1166.62. So we can say 167 equals to 1167. Alright, then this is 12x plus 14y equals to 12 open bracket 20 plus 14 open bracket 75. So this is 12 times 20 giving us 240 plus 14 times 75 giving us 1050. So 1050 plus 24 gives us 1290. Then for this, 12x plus 14y equals to 12 open bracket 50 plus 14 open bracket 20 equals to 12 times 15. 600 plus 14 times 20, 280. This gives us 880. Then for the last one, 12x plus 14y equals to 12 open bracket 50 plus 14 open bracket 0 equals to 12 times 50, 600 plus 0 equals to 600. So from this now, we can say the highest is 1290, and we can now advise the management. The management should choose option C, which is producing 20 units of X now, representing the deluxe model, and 75 units of what? Y representing standard model, in order to have an optimal value of how much? 1290. So that will be all for linear programming when graphical solution is given. So in our next video, we'll treat linear programming using simplex method. So if you have any questions, you can drop it in the comment section. Bye.